All right, good morning and happy Wednesday. I'm planning on doing the LeetCode Daily Challenge for today, July 5th. Okay, so here we go. July 5th. Longest subarray of ones after deleting one element. Oops. I wanted to see if I solved this before. It looks like I have a couple years ago, only in JavaScript and C++ though. Delete one element. Okay, so we want the largest chunk of ones between a 0. Oh, we must delete one though here. Okay, one's to the left and one's to the right. Okay. Yeah. All right. So pre-process the input from left to right and right to left, tracking the run length of ones. Then perform, this is the game plan, hold on, 7:22 a.m., 7:22 a.m. And here's the game plan. And then perform a linear scan for each ith index candidate to be removed to find return best. A best or best. And then it's the cardinality of limit array. A, L is 0 times n, R is 0 times n, or I in range n. Pre-process the input, let I be the index 0 through n minus 1 inclusive, j be n minus 1 down to 0 inclusive, so j equals n minus 1 minus I, and then L sub I equals L sub 1 plus L sub I minus 1, right? And then R sub j be R sub j, so R sub j plus 1, right? Build the past upon the, or build the future upon the past for pre-processing the input. For O1 lookups next, right? So then L sub I minus 1, if 0 is, let's say I minus 1, otherwise 0, build the recurrence relation upon itself. A sub I plus R sub j equals A sub j plus equals 1, right? Or it is 1, right? It's either 1 or 0, plus R sub j plus 1 if j plus 1 is less than n, otherwise 0. Okay, there's our recurrence relation, and then for each ith index candidate to be removed. L sub I minus 1. Candidate equals this, and the best equals maximum of itself. And the candidate would be L sub I minus 1 if I minus 1 is greater than equals 0. Plus step plus 1 if I plus 1 is less than by 0. Okay, and that's code. Let's see what happens here. 3, 5, and 2. 3, 6, and 2. Okay, by 6. I'm getting 6. Oh, it needs to be reset back to 0. Plus, okay. Reset this back to 0. A spy. if A sub I, if R sub J. Otherwise, if it's not set, then we're not gonna add on to it, right? Oops, L sub I, R sub J. Okay, that looks good. Uh-oh. If L, oops, A sub I, A sub I, A sub J, right? Okay, that is right. Okay, so if it is set, then update that. Okay, that looks good. 722 to 726. Yay, about 4 minutes. 4 minutes for game plan plus, oops, plus implementation and Python 3, which is accepted. Yay. Okay, so 4 minutes isn't too shabby for a recurrent installation like that. So that's cool. And then I guess maybe see if we can, I guess, yeah, it's a decent solution, right? Let's see what we came up with previously. Sliding window. Oh, sliding window with most 1-0. That's cool too. What I do? Prefix sums. Okay, I did the prefix sums from left to right and right to left. Looks like I did this during a contest too. That's cool. Oh, I did actually pretty decent on this contest. It was like about 5 minutes each, and then I missed Q4 there. Anyhow, let's just get rid of this. Okay, actually, this is a form of dynamic programming the way that I've written it. Might as well write the art of dynamic programming, right? Which I think is cool. I think well-written code is a form of art. Okay, so anyhow, I've got this guy. Hopefully spread the word. I believe it is helpful. Yeah, so we can reduce the asymptotic bounds for each index to candidate movable candidate. To allow lookups for each ith index removable candidate. Yeah, pre-processing the input, the input array from left, from left to right and right to left. Tracking the consecutive run length. It's the run length. Run length of consecutive spell and R, oops, correspondingly. Okay, that sounds good. And right, the code is self-documented, so you can just read it and it's written well enough where we can actually see what's going on, right? Okay, Python 3. Last. Already, there's Python 3. Okay, so the other way that the dude did it was sliding window, right? Which is kind of cool. Might as well write that real quick. Sliding window is more memory efficient. And Well, from the sliding window, though, how would you consider this case? Right, you have to delete at least one element. So, yeah, whatever. Let's just keep going with what I did. Right, it's not perfect, but it's a decent solution, right? Yeah, size. Oops. Too high. It's okay. Size in. Size in. 4, 0. This is in. This is 5. Oops. J is in minus 1 minus I. If a sub I, then L sub I equals a sub I plus 0 is less than or equal to I minus 1, and we'll also add L sub I minus 1 by 0. If a sub j, then R sub j equals a sub j plus, if j is less than plus 1 is less than n, R sub j plus 1 by 0. All right, there's our recurrence relation. And then consider all ith index candidates to be removed. Candidate is this plus that, which would be L sub I minus 1 if it exists. 0, and then R sub I plus 1 if it exists. This is the maximum of itself, and the candidate return the best. Best to be stick it up here. Oops. Okay, something like that. Oh, what is it complaining about? If this, then that equals that plus that. If this expected. Oh, we need a question mark. Oops. The ternary operator is a question mark followed by a colon, right? Oops. Okay. Simple mistake. Oh, dude, I'm like consistently typing this wrong. Better than inconsistently, I guess, but yeah. Here we go. All right, that's cool. There's C++. Let's do JavaScript. Keep track of time. Should only take a couple minutes, right? Sorry, you know what I'm doing. I don't really need to read the problem statement or anything. And there's a dot length. Let's just do this. Let's just stick this in body. And say dot length. L, those arrays in, fill with zeros, R's arrays in, fill with zeros. Oops. Zeros. I. J equals n minus 1 minus I. Right, so J goes from right to left, I goes from left to right. If A sub I, L sub I equals 1, 0 plus A sub I. If A sub j, then R sub j is A sub j plus, so that was an n. So R sub j plus 1, 0. And then here we'll return our best solution. You know what, we can return this more succinctly, right? Just do this guy, and then instead of having the best and everything, just return low dash range 0 to n minus 1 non-inclusive dot map each ith value to this plus that. That is, if I minus 1 is less than or equal to 0, then L sub I minus 1 is 0 plus if I plus 1 is less than n, then R sub I plus 1, otherwise 0. And then we want the maximum of that spread. Okay, something like that. 734 to 736. Compilation issue token. Oops. I don't know why I keep typing it like that. Question mark colon. Okay, that looks good. And we'll go back and clean up the Python 3 solution. Right, we can do that functionally. It's a little bit cleaner. You can see exactly what it's doing. Okay, let's go back here. This guy, choop, and then get rid of best. Okay, churn maximum. This plus that for in range in. This should be L sub 1 if this one is greater than or equal to 0, otherwise 0, or sub I plus 1. If I plus 1 is less than n, 0, and the maximum of those. Looks good. All right, that's cool. A little bit cleaner. Okay. This sounds a little bit more verbose. It's fine. C++, I can write it functionally, but it's going to be, pretty sure it's going to be ugly. Let's see what it looks like. Oops, hold on. This. Let's write this functionally. The maximum element of this plus that. Turn this, turn to the object and slick max C++. The structure that I'm looking for would be maximum element character. It's not what I want though. Yeah, we'll just leave it, right? I know it's going to be verbose and ugly if I write this functionally. Okay, so let's do this in Kotlin. Okay, it is 7:39 in the AM. Star, let's see that size. Oops. Oh, what's the terrain size in zeros? R is the same thing, right? So we'll pre-process the input to left to right and right to left. For I in 0 until n, j is minus 1 minus I. If a sub I is equal to 0, then L sub I equals a sub I plus if I minus 1 is greater than or equal to 0, would be L sub I minus 1. Oops. Minus 0. If a sub j is equal to 1, then R sub j equals a sub j plus if j plus 1 is less than n, R sub j plus 1 is 0. All right, and return the range 0 until n dot map hi index to this plus that, and then take the max unwrapped. If I minus 1 is less than or equal to 0, then L sub I minus 1, otherwise 0. Whereas if I plus 1 is less than n, then we'll take R sub I plus 1, otherwise 0. And the maximum of those, 739 to 741. Uh-oh, it's okay, it looks good. 741, about 2 minutes. Looks good. Okay, I'll do rest last and then we'll call it a day for the daily challenge at least. Yeah, there's a couple of ups on it maybe later on this afternoon. So. Equals length. And fill it with zeros. Oops. Zeros as well. 0 to n minus 1 inclusive. Whoa. Two. 72. Okay, that's all she wrote for the daily challenge for today, right? So using the art of dynamic programming, we can see solutions from left to right to left, using the right side of the brain, which conceptually can understand holistic ideas. Right, so we reduce the asymptotic bounds to O on lookups for ith index removal candidate. Candidate is no longer verbose. Via pre-processing the input array A from left to right and right to left, tracking the run, I guess the run length. I guess checking the length of consecutive ones. And now correspondingly. Yeah, that looks good, right? Yeah, I think it's cool. Okay. Get you all next time.